So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 7 WAEC repeated questions to answer on the topic motion. So guys, this video will be about solid friction, so ensure to stay till the end of this video. Let's go ahead and start with the first question here. It says, which of the following statements about solid friction are correct? It's I is a force. II occurs between the surface of two bodies in contact. III depends on the area of contact. So guys, the answer to this question is I and II. So that corresponds to option B here, guys. I and II only. So let's go ahead and consider the next question, guys. So the next question we have here is question number 2. It says, a wooden block of mass 1.6 kg rests on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton, calculate the coefficient of friction. So guys, for us to calculate the coefficient of friction, we are going to use the formula coefficient of friction mu is equal to the frictional force over the reacting force. So guys, in this, the frictional force here is 8 Newton, then the reacting force will be the weight of the object, and that's 1.6 kilograms times the acceleration due to gravity, which is 10. So that's 16 here, guys. 8 over 16 is actually 0.5. And that's it for this question, guys. Option B is the answer. So let's go ahead and consider the next question. So the next question we have here is question number 3 here. It says, a block weighing 15 Newton rests on a flat surface and a horizontal force of 3 Newton is exerted on it. Determine the frictional force on the block. So guys, in order for us to determine the frictional force, we'll first of all find the coefficient of friction here, which is actually the frictional force over the reacting force here, or let's say the force in action over the weight of the object here. So guys, for this here, we're going to have that since a force of 3 Newton is exerted on it, this is the force in action, and then we'll divide this by the weight, which is 15 Newton here, in order to get the coefficient of friction. So guys, if we do that here, we're going to have 3 Newtons over 15 Newtons, which is actually 0.2. So guys, if we want to find the frictional force on the block here now, we're going to use that F is equal to mu times the weight here. So guys, the mu is the coefficient of friction here, guys, which is 0.2, then times the weight, which is 15 Newton. So guys, that will give us 3 Newton. And that's it for this question, guys. 3 Newtons is the answer here. That's option A. So let's go ahead and consider the next question, guys. So the next question we have here is question number 4. It says, solid friction, like viscosity, is A, independent of the relative motion between layers, B, independent of the surface areas in contact, C, in opposition to motion, D, dependent on normal reaction. So guys, the answer to this question is option C. Solid friction, like viscosity, is in opposition to motion. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 5. It says, a body of mass 25 kg moving at 3 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of sliding friction. So guys, for this here, for this question, we are going to have that the coefficient of friction here is actually the frictional force here over the reacting force here, or the acting force over the reacting force here, or the force of action here over the weight of the object here. So guys, in order to calculate the force of action here, we're going to use mass times acceleration. That's the linear acceleration. Whereas for the weight of the object here, or the reacting force here, we're going to use mass times acceleration due to gravity, and that's mg here. So the mass of this is actually 25 kilograms here, but then we don't have the linear acceleration, but yet we have the acceleration due to gravity. So in that case, we are going to have that mu, which is the coefficient of friction, is equal to ma over mg. So ma is equal to 25a, where mg is 25 times 10, that's 250. So in that case, mu is equal to 25a over 250. But then if we want to find a, we can actually relate it to the equation of motion, as Newton's equation of motion, and then we are going to have that v square is equal to u square plus 2as. So guys, from the question here, if we have to impute the values for v squared, u squared, and 2as in order to solve for as, first of all, we have to recognize that we are solving for the acceleration here. So in that case, we are going to make acceleration the subject of the equation here in order to get the acceleration. So if v squared is equal to u squared plus 2as, it means that 2as is actually equal to v squared minus u squared. So in that case, a is equal to v squared minus u squared over 2s. Alright, so guys, at this point we can now impute the values for each of these. So v squared is going to be 0 since the body is brought to rest, and then u squared is going to be 3 squared since it started moving with an initial velocity of 3 meters per second. So this will be over 2s, that's 2 times 2.5. So 2 times 2.5 is actually 5, guys. In that case, 0 minus 9 is equal to a negative 9. So the acceleration here will now be negative 9 over 5. So guys, that's negative 1.8. But let's take note that this is the deceleration. Negative 1.8 is the deceleration because it was brought to rest. So in that case, the acceleration will now be the negative value of the negative 1.8, and that's positive 1.8. So that's 1.8. Acceleration here is 1.8. So if we impute these into the overall equation we had earlier on, so that's 25 times 1.8 over 250. So guys, that will give us 0.18. So that's it for this question. Option D is the answer to this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, in which of the following situations is friction not useful? We have A, operation of grinding machine, B, application of brake, C, walking, D, moving piston in a sleeve. So guys, obviously the answer to this question is option D here. So we have applications of friction in operating a grinding machine, in application of brakes, in walking as well. But guys, friction is not applied in moving piston in a sleeve. So that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 7 here. It says, which of the following statements about static friction is correct? It's A, depends on the weight of the moving body. B, depends on the area of surfaces in contact. C, is independent of the nature of surfaces in contact. D, depends on the relative motion between the surfaces in contact. So guys, the answer to this question here is option D. The static friction actually depends on the relative motion between the surfaces in contact. And that's it for this question. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community where we'll post major updates on WAEC examination. So this will help you a lot even as you prepare for your WAEC examination for the year. You can join this channel community by hitting the join button below. And we'll see you right there. Thank you once again for watching this video and see you on the next one.